Buenas tardes a todos. Recibimos con mucho gusto a Gunnar Siedler, quien es el autor de este sistema Metigo MAP, que va a ser motivo no solo de la conferencia del día de hoy, sino de una serie de actividades que están programadas esta semana en torno exactamente al sistema Metigo MAP y a todas sus características que lo hacen ser un software francamente muy interesante para la conservación del patrimonio cultural, tanto bien inmueble como bien mueble, que seguramente podrá sernos pues una herramienta no solo de registro, sino de un registro administrativo, de un registro muy amplio, muy sistemático, muy profundo en términos de lo que es un mapeo de alta resolución y de alto cubrimiento en todo lo que son pues, los relieves, estructuras con pues, lados múltiples, y además todo lo que esto implica en términos de los levantamientos e integración de información para un sistema que, además de sernos útil para tener un registro absolutamente documentado, del cual, como sabemos, se deriva una factibilidad de aplicación en términos de la organización de proyectos, de la administración, de la cuantificación, y que finalmente presenta una serie de características que nos resultan a todos francamente muy interesantes en términos de una más ágil, más adecuada documentación y factibilidad de derivar de él muchísima información. Por tanto, la verdad es que agradecemos de veras profundamente a Gunnar Siedler, que está con nosotros en México, en el Instituto Nacional de Antropología, tanto en esta Coordinación Nacional de Conservación como con la Escuela Nacional de Conservación, Restauración y Museografía, con quienes obviamente estamos trabajando en colectivo para hacer posible la difusión de estos sistemas, de este tipo de software que nos permitirá un registro y documentación, como decía, mucho más amplio. Hoy, como señalábamos, esta sesión pues será esta conferencia, y a partir de mañana empezará una serie de prácticas y de experiencias posteriores, por las cuales pues, le agradezco también, y está con nosotros Luis Carlos Bustos Reyes, que seguramente muchos de los que están aquí presentes ya lo conocen. Él es el coordinador académico de la maestría en Conservación y Restauración de Bienes Culturales y Inmuebles de la escuela, con quienes por supuesto estamos trabajando, y les cedo la palabra.
Gracias. Bueno, a nombre de Andrés, que es el director de la escuela, hoy como en otras ocasiones, también está ocupado atendiendo otras cosas de la dinámica administrativa de la escuela. Sin embargo, sí hacer presencia, entender que desde la perspectiva de la formación, ya desde hace un buen tiempo en nuestro país empiezan a aparecer una serie de plataformas y programas desarrollados buscando ahorrar, ¿no?, mucho tiempo, pero no solo mucho tiempo, sino buscando integrar un montón de cosas, ¿no?, que siempre tenemos en la cabeza para desarrollar, y que en el sentido de las posibilidades de desarrollo, si antes se invertía mucho tiempo y se iba implementando, es decir, una serie de como cuestiones artesanales, es decir, y se va trabajando de una manera muy artesanal, recuperando, generando toda esta información, tener la posibilidad de una plataforma que sintetice todo ese trabajo que también que desarrolla procesos de comprensión, es muy valioso. también es un reto pensar ahora cómo no perder esos procesos comprensivos si vamos a empezar a tener una relación, ¿no?, estrecha con este tipo de programas. También es algo importante. Sin embargo, la tecnología y estos desarrollos se van a hacer presentes. Es una necesidad empezar a utilizarlos, incorporarlos en la formación para la restauración, para la documentación, pero sin perder de vista que la parte humana que opera todas estas cosas y que hace los procesos más significativos, ¿no?, para la conservación del patrimonio, no se puede perder, ¿no? Entonces, hay un reto importante siempre en la academia de entender cómo detonar estas experiencias de aprendizaje de estas plataformas. Empezamos, ¿no? Se va a empezar a diseminar el conocimiento de Metigo MAP como una alternativa para nuestra labor, y bueno, junto con eso iremos aprendiendo y entendiendo cómo en los procesos formativos podemos ir dándole valor a esta parte sin perder, ¿no?, todo el valor que tiene la persona que recupera la información y que la trabaja y la procesa a través de todas estas plataformas. Gracias por venir a traernos todo este desarrollo. Gracias a Marlene, que siempre su iniciativa de vincular todas estas cosas es muy valiosa esa inquietud, y al final pues en nuestra comunidad detona cosas importantes. Gracias, Marlene.
Bueno, a mí solo me queda como dar también agradecimientos a pues esta idea o este sueño que empezó hace 2 años. Me gustaría nombrar a una restauradora que es egresada de esta escuela y que empezó desde Alemania a hacer el vínculo con Gunnar Siedler. Ella es Sandra Bucher-Fiutza, que ella pues empezó a hacer este enlace dando una primera conferencia acerca de nuevas tecnologías. Creo que este tipo de programas finalmente nos acercan pues a la vanguardia de los registros, la documentación, la toma fotográfica, ¿no?, del patrimonio cultural. Entonces me parece que estar como enterados de qué está sucediendo en el mundo y tener también la capacitación para ellos es muy interesante. La otra cuestión que sería muy bueno que pudiéramos generar en todos estos días del curso es que estamos restauradores de bienes muebles y restauradores de bienes inmuebles como una sola comunidad. Entonces va a ser como muy interesante que podamos estar desde también la perspectiva institucional, la perspectiva privada, y que podamos generar diálogos, comunicación entre nosotros, que creo que también eso es muy importante. Muchas gracias a todos por estar aquí. Muchas gracias también a Liliana, a Andrés Triana, Guadalupe de la Torre, Luis Carlos Bustos, porque pues, sin su apoyo no hubiera sido posible. Y muchas gracias, García.
Nice to see so much people, so much interest. My name is Gunnar. I'm an engineer for surveying and photogrammetry. I'm a conservator, and we provide services for conservator. He makes documentations for conservation and for architects. And I give you today 3 presentations. In the first step, I show you the work in the field of photogrammetry for conservation. It's interesting to understand at first which type of documentation the conservators in Germany use for documentation, use for mapping, with different programs, yes? Which type of quality we produce in the field of documentation. We start with our firm in 1993, and for a long time we produce the services digital in the office, and then we print it out, and then the conservators take the pen and make the mapping by manually. And in the time of, I think, in the end of the 90s, around 2000, we get 32-bit systems by Windows, and we can buy digital cameras, and there was a changing in the usage of digital data, and we start to develop the software for conservators, that they can make rectification for their small own projects, and then they can start to make the mapping. And in the middle, the second part, I give a presentation from the other side, not from our service. How you have to define the quality for documentation, if you are interested to organize this. Yes, I give some features, what is necessary to get a good documentation. And the last part, I speak about Metigo MAP. The functions, give an overview over the functions. And the next days you will see more of the training. So I will start with the first. Okay, this are the parts of our work. We speak about 2D image rectifications and mosaicing of images. We speak about unwrappings, 3D documentations. We speak about the evaluation of historic photos and total station of surveying. It's only our work. We don't speak about this today. We make also for painting conservations, documentations by UV light or infrared or X-photography. We speak about the software development. Okay, this is of the beginning. The images are very old, in the 90s, maybe 94, 95, where we start to make the first digital rectifications. And the first idea was we can make rectifications to get one plan, to have a mosaic to one plan. Yes, you see the roof, and you cannot take one image for the tower, so you must make from the left and from the right side. You measure coordinates, you can make the rectification, and the conservator get one plan. This is the main idea, yes, to make rectification, to make mosaic. And if the project is too large, you come with a total station, measure coordinates over the wall, and you can make 4, 5, 6, 7 images and more, and the result is a mosaic of the images. And for a long time we use large format cameras, 13 to 18 centimeter on class plates and 4 to 5 inch, and we scan these images. We measure the coordinates by total station, there's no changing in this. We make a high resolution scan and the rectification of the images. The mosaicing by colors we do in Adobe Photoshop since 20 years. And at the beginning we speak about scale and resolution. What means resolution? Resolution 400 dpi, 400 dots per inch. That means 400 dots per 25 millimeters. 1 dot by 400 dpi is 0.06 millimeters. And then we take the scale and multiply this with the scale. And so we understand, maybe by a scale 1 to 5, you see 0.3 millimeters. Or by 1 to 10, 0.6. Or maybe 1 to 50, you see 3 millimeters for 1 point. That means at the beginning, before you start to make the documentation, you must define the quality of the object. The customers come to us and ask us for the price, how much will it cost for image 1, 10, 20, and so on. Depending on the, I will talk more about this later. And in Metigo MAP we have a planning for photography. You select the size of the object, how many meters, the width and the height. Then you select the scale and the resolution. We calculate to use the size of the image pixel on side of the object, as in the scale 1 to 1. And then you can make the decision, is it enough, I need more resolution or not, must I change the scale? In the next step we take the size and the scale and the resolution and we calculate the size of the image, how large is the image. And then you can select one of your cameras, you can select the sensor of the cameras, and we say to you, you must take 4 images to get this resolution. Before you go out to take the first images, 5 minutes to test the size and the resolution, and then you know what you have to do to get this. Yes, it's very easy. In our work, we really work with total station, we see the total station, and so we measure coordinates on the wall. We work with flashlight or with daylight, polarization filters and so on. We have a lot of equipment. And then we make the rectification of the first image by these coordinates, and the next image, and the next. And then we can write out a multi-layer TIFF file. We go to Adobe Photoshop, and you get the result. Maybe this is a wooden object, on the scale 1 to 10, I think. And you see the resolution of this. 2D image rectification is a compromise. That means we define one plan. This plan has a scale. You see, this is the plan with the scale. And all things which coming out, they have a small mistake in scale and in perspective projection. They are a little bit more in sides, and if they are deeper, they are smaller, yes? And I go one step back, a moment, sorry. You see the walls, it means these parts are the scale, and the window, it's only for nice viewing, yes? We make the photo in front of the window. There is no scale. And for the documentation of conservation, we make an extra rectification for the windows and the side left and the side right and the side left. Okay. It's an example for this great wall. It's not possible to take images from one position. Yes, we must go to the next house and we take some photos for the second floor, and we must go to the balcony. Takes the photos, and you see the rectification. This is a part of 3 images. You see one original image, and you see the complete wall. And this is in the time of 1998. That means we print out these parts, these segments, on the sides of format A3, 42 centimeters to 29, for the analog mapping, yes? And later we get some digital image. It was for a long time the normally work. Okay, the next, sometimes it's not only enough to calculate how many images we need to get the resolution. Sometimes we must do more images to follow the structure of the object, so that we can make the good model again. You see the paintings in the middle, so it's necessary to make one image only for the painting. So we can follow the structure of the sailing. And you see the result. It's the same, yes, we take one image before the window, one image before the painting, and the next, and the next. It's only a question of working time. We must discuss this before with the customer. Is it too much work, too much cost? Or should we take maybe every 2 windows, one image, depending on the project. It's the same, yes, you can do only one image, but we do 3 images. So you every time look in front to the window, yes? So you have a good feeling for good documentation. And sometimes the people use this for, they say it's enough for mapping, if there is not much things to make for documentation. And sometimes we make special unwrappings for the windows, depending on the project. Maybe you have seen the printing out of the marble floor. It's a room 30 meters to 20 meters. And we have to take over 50 images. This is one image, 4 to 5 inch. And scan with 2,500 dpi. This is one image with 10 to 12,000 points. And then we have measured coordinates, we have made rectifications. And then you see the small fields. That means we have print out every stripe 1 to 1, 1 meter to 2 meter 50. And the problem is the house is in the time of 1770 or 80 built in 3 years. And they have cut the marble inside in the house with water. And every time they have problems with the wooden structure. There's too much water in the ceilings. And now they must open these parts of the floor to bring a new construction by steel below of the floor. And that's why we have to print out the stripes so they can take the segments, put them on the stripes and can take it back. Normally we make no documentation 1 to 1, normally not. Normally 1 to 10 or 1 to 20 years. For this project we have done this. This is one stripe, 1 meter, 2 meter 50, and this is the resolution 1 to 1. And you see the problems, they must do a lot of repair of the work. Okay. We go to castles or to museums, and normally we come and makes the complete documentation of one room. They need a lot of time to remove all the things, the equipment and the objects, yes, and then we have 1 or 2 days time to take photos from the floor, from the ceiling, and from all the wall. And then we finish the work and they get a DVD with all the image plans, normally 1 to 10 or 1 to 20. It's a little bit depending on the material, which detail you need to see. This is the single documentation of one floor. And this is only the nice image for the architect, not for the conservator. Yes. Yeah, because it makes the documentation by room, and so we have put some place on scale 1 to 50. Okay, this was the first example was only for rectification by 2D, for one plan. And now we speak about unwrapping of curved surfaces. You see the tower, yes, it's like a cylinder. And we go out with the total station and we measure at first the horizontal section. So that we know the position of the cylinder and the size of the cylinder. And then we're going around taking photos and we measure 3D control points. Now we need 3D control points so that we can calculate the position of the camera and the direction of the viewing. We speak about the photogrammetric orientation of the camera. And then we know the position of the cylinder, and we know the position of the camera, and so we can project the image data to the cylinder, and we can calculate this unwrapping. Normally, yes. And we can do this outside, we can do this inside, it's the same, yes. And the people say it's interesting to have one plan to make one mapping and to get an overview of the condition of the whole object. And we can do this with daylight images and with UV light images or with historic images. And so they get the combination of different types of images, they can put them together, they can overlay them, and they can make the mapping in one mapping project. And switch on off maybe UV light or daylight. That's why we make the mosaicing of curved surfaces. At the beginning it's a little bit more work for documentation, but later to save a lot of working time, it's easier to make the documentation for conservators. And you have a good overview of the project. It helps to understand the images and so on. It's the same, it's an unwrapping from inside, yes. 3 images, measure coordinates. Okay, it's a baroque. I think you have the same things here. You see the church, you see the baroque cylinder, and this is one image. We have measured the coordinates for the calculation of the orientation. And here you see the projection of the cylinder for the first image. And then you see the unwrapping of all these images. That means for every section we take 3 images, one to the left, one to the right, and one to the top. That we have a good resolution to the images. And then you see the stripe with 3 images. It's depending on the scale which we should do. And then we count the images and we can see how much it costs. And this is the example. Sometimes, okay, at first we have to speak about 2D rectification for plans, yes. Then we have to speak about 2D curved surfaces, yes. It's nearly 2D. It's a curved surface, but it's only a cylinder surface. In the next step we speak about 3D auto projections. And we need the support of laser scanning so that we can measure the surface and then we use it. Okay, you know there are different types of laser scanning. It costs a lot of money, and I think you have also seen a lot of bad documentations by laser scanning. Laser scanning is good to measure deformations, in my opinion, or to draw some horizontal and vertical sections. But it's not a good tool to make the documentation for conservator, because the resolution is not good enough. So we must, before the project we start with the documentation, we must make a discussion when we need the laser scanning. We need it for deformation analysis, then we take it, and we need it if we make 3D auto projections. For this we use laser scanning, not more. We have some problems in the accuracy of the measurements, yes, by laser scanning. If you have industrial projects, you can use mathematical filter functions and you can correct it. But if you have a monument project, nobody knows these are profiles in the stone, or these are damages, or what is this, so we cannot use such functions. And you see the problems by laser scanning as one laser scanner from the left side, one from the right side. And this is normally one line, but the measurement from 2 directions gives you 2 results. And so I say normally laser scanning is good enough for documentation in the scale 1 to 50, 1 to 100, not more. by the accuracy, yes? If you go to the reseller of laser scanners, they speak about accuracy in the field of millimeters, but it's not correct. It's a small testless laser scanner from a German university that exists. You see this object, and you see it's like a Siemens star, yes? And normally, we have two surfaces. We have this surfaces before, and in the background we have the second plate. And we take the laser scanner, and normally we should have two black lines of points on the first surface and on the second surface. And now you see the result of the different types of laser scanners. You understand? It's terrible, yes? I think maybe this can be the best one, but you see a lot of points between this, yes? And you see this, it's terrible, yes? Or like this one, it's not a result for laser scanning. If the reseller of laser scanners speak about accuracy, they mean, how can I say, the measurements in the laboratory. They have white walls and they have defined control points. They have special function to measure control points in high accuracy, maybe white balls or special targets, yes. Then they make transformation between these points and they get results of 2-3 millimeters. The problem is, laser scanning is depending on the reflection of the surface. And we have a lot of different problems. The first, we have white and black stone. So we have different reflection and distance. If you make the measurement by black and white marble floor, you get difference in the distances 1 to 2 centimeters. By a measurement distance only of 2 or 3 meters. That means the color is important for the reflection. The next is the structure of the surface. If you have a fine structure, the next problem is if you have water on the surface. If you have maybe biological things on the surface. And it's also very important the angle of the measurement. So we have so much problems, and you see the result of this. And that's why I say 150 or 100 is enough, not more. This is not an architectural laser scanner, this is done by an industrial laser scanner. In Germany you must pay for this over 100,000 euro. It's too expensive for documentation in the field of conservation, yes, we cannot afford this. And sometimes we can rent it by firms who works for car production or for, in these fields they have enough money to buy this. And we have done this only for reconstruction of the profile lines. They have some stones, they will repair the stones and they will reconstruct some stones. And so we have makes some scans to get the profile lines for the stones. Okay, now we speak about the usage for the scanning data for us, for our work. You see the surface of the laser scanning. We make 2 images and we measure coordinates to orientate the laser scanning data and to orientate our images in the same coordinate system. And then we use the surface of the laser scanning to calculate an autoprojection. And now we have no perspective mistakes in the Dipl. Now it's an orthogonal projection of all. You see the lines of the stone are horizontal. You can compare this. This is 2D image rectification only on this plane. And you see the mistakes in the window. And you see the auto-projection. If the architect comes and is interested to draw and plan, he's very interested to get this result. For the stone conservator, normally it's too expensive. The cost relation in Germany, we say it's 1 to 3. We need 3 times more money for buying the scanning data and for the orientation of the images and so on. And the conservator can take his own image, use our software, he measures the distance to the width and the height, so he can make the rectification. And for 3D objects in the field of stone conservation, they must make a documentation of manual measurements. So it's not necessary for him to have this high quality of auto projection, because the Dipl I can also not measure here. It's interesting to see the height, but it's also not possible to measure the Dipl, yes? And so we must discuss this every time if we use it or not. It's a question of money and working time. Sometimes architects use the auto projection by the intensity of the laser reflection. Yes, the measurement of the if you have a white wall, you get more reflections than on a black stone. And so you can calculate a grayscale image by the intensity. And this is only to the rectification, and now we see the problem. You see the surface of the laser scanning information. For the architect, it's good enough to draw a plan. Yes, you must make it different. But for the stone conservator, it's nothing. He needs the image on the right side, and he do not need the exactly auto projection of the stone. He's much more interested to see the details, maybe the damages in the stone and so on. You understand? Okay. So now I show you some examples for the usage of auto projections. You see the ceiling of the room, the surface, and then I can take one image, and now you see not the rectification on the plan, it's the correction over the whole surface model, yes, and the first image, the next, and the next, and the next, and the next. It means they have all the same geometry. And then we can make the export as a multi-layer TIFF file to Photoshop. It's the same, if you have curved surfaces with different directions, yes, multi-curved surfaces like this. You see the ceiling of the church, and I have one direction of this. This is the mean cylinder for the unwrapping. And we have also these directions. And it's not possible to make a mosaicing of all these images which we need. And so we use the surface model, and this is one oriented images. Now you see the result over one ceiling. I think it's, if I see this, maybe in Germany, 6,000 to 8,000 euro for this image plan. It's a lot of money, yes? But if you go to the church to build the scaffolding that you can work at the ceiling, it's much more money. Yes? Every time you must make the relation to the costs for the whole project. And then you can say maybe 1, 2, 3% can be used for documentation. You must see the relation. How large is the project, how much money we can use for documentation. And so I think for this ceiling, it's not much money. So you need much more money for conservation, for organization, for scaffolding, and so on. And they save a lot of working time to use this plan for documentation. They can calculate at first how many square meters we have to repair. In the next step, they can make the documentation. They save a lot of working time, and they can organize the costs, and they can organize the work. This is a resolution. If you look to the detail, you see some problems by laser scanning. Maybe if you look to these edges, it's not possible. Okay, but nice, yes? It's the same example. It's Bridgestone from 19th century, yes? It's not for, how can I say, not for cultural heritage. We do this for architects. They are only interested to get a good image plan, to organize the work, for repair the joints, and for exchange the stones. That's all. You see the result. This is an auto projection. Yes? Sometimes you must calculate the compromise before. You see this room. We have made the laser scanning to use it for the ceiling. We have looked to the auto projection, and we have said it's not good enough. So we have said for the walls, we make only 2D image rectification. This is only 2D with perspective, it's no problem, but in good resolution. And we use the scanning data for auto projection of the ceiling and for unwrapping of this on the scale 1 to 10. The floor, we make 2D image rectification, we measure only coordinates. And we use the scanning data for the analyzing of the deformation. You see the problem in the wooden construction, like here and here and here. So you know where they must work. Okay. It's a complete documentation of the room, the floor, the walls, and the wood and the ceiling. It's on site, I think, 2 or 3 days work, to taking the photos, measure the coordinates, and make the scanning data. And then we have, I think, 2 weeks work in the office. It's an example for the combination of daylight images and UV light images. That means we use this 3D surface model that we can calculate the orientation of the images from today. We make also UV light images from today. And we can also use historical images from the time from 1940 until 45. They have started in Germany during the World War to make documentation with color slides of all war paintings. The thinking was we can repair this later, yes. It's strange, but today it's a good documentation, yes. So we calculate the image from today and the image from 70 years ago, and you can overlay them by the machine, yes, in the same quality. This is the result of the unpacking of the scene. This is the detail, the scale 1, 2, 5. It's from medieval time, I think 1100 from this time. It's nice. This is an example for deformation analysis by laser scanning. You see the noise and the points, but if you go some step back, then we see the deformation. For this is a good example, yes? The image plane in the background, we have made this 2D image rectification. Okay, that's an example of deformation analysis. We measure, at first we make the scanning, then we measure profile lines automatically by the data of the scanning. And then you can see the changing in the walls, how to repair. Okay, we go to the next. We speak about stereophotogrammetry. It's a little bit history. Yes, for a long time, I think from the 60s until the 90s, there was only one way to get good graphic documentations. We work with stereophotogrammetry. We have glass plates, 13 to 18 centimeter. We make 2 images for the left and the right A, measure coordinates in the object. Today, maybe you go to the cinema and you use glasses just to see the stereo 3D film, yes? And normally we have large, how can I say, a large stereo evaluation table. It's like the table of the sides. The cost maybe 200,000 euro, and you have 2 optic for the left image, for the right image, and you're looking through the optic and you see in 3D image, and you measure with a control point on the surface. So we make stereo model from the first, from the next, and you see the 3D viewing on the object, and you can make the drawing. And I think it's too expensive for today. Today, normally, we make only 2D image planes. And sometimes we make drawing if we have problems for deformation analysis. But then we make the combination. We make not the drawings of the stones, we make only the mean architectural lines. And the documentation of the stones they can find in the image plan. So it's a compromise. Today we use stereo documentation for automatically functions to get 3D coordinates. It's an example. Yes, you see 2 images, 2 SLR cameras, it's Canon 5D, and it's a fixed stereo base for 1 meter. And the software will automatically find the connecting points, and it will measure some control points on the surface for the scale. And then we can calculate by matching of identical points the 3D coordinates. And you get the surface from one model. And you can calculate the errors and the mistakes. So you make one model, we make the next model, we make the next. Then we can combine them to one surface model. So we can calculate the surface of the apps, and then we can use it for the auto projection of the apps. For us, it's economic decision. Sometimes we use laser scanning, and sometimes we use stereo images to calculate the surface. If we have a small church, it's easy to take some stereo images to calculate the surface. If we have a large church, it's easier to take laser scanning. We make the decision by working time and by cost. Now we can. It's only a nice image. In Germany at time, no conservator works in 3D. I think today we have software with 64-bit, Windows 7, Windows 10, and maybe you can buy for 500 or 4,000 euro a computer with 8 or 16 gigabyte RAM. That means you can work very easy with large images, only in 2D. If you are interested to work in 3D, you need OpenGL. It works on the graphic card. And so you must buy expensive graphic cards for 2 or for 4,000 euro and more. And it's in Germany also expensive, too expensive for conservators. So it's not necessary. That means he works inside the 3D theaters to calculate auto projections. But the result of our work, to 99%, is a 2D image plan. So the conservator can work easy in the mapping software with 2D. It's reality. Sometimes at conferences you see a lot of presentations about 3D point clouds and so on. It's not reality. It's an example of the unwrapping. It's the auto projection, and this is the unwrapping of the colored and this daylight image, and then the next with 3 UV light images. We have 4 UV light lamps to make the, and you have the same result by the colored with UV light, so you can put them together and can make the mapping. It's the unwrapping of the apps, and this is, you see, you have 2 images to analyze the overpaintings and so on. Okay, you know this, I think. You can use digital cameras for the part of the UV light and for the near infrared. And so we make also infrared documentations by paintings to see the drawing before, yes. Or we make the documentation by UV light to see the changing of the material with time. It's a UV light image. That means in our software Metigo MAP we have functions for automatically matching. We make at first with our large image format the image plan with daylight, and then we take the UV light camera with to take small segments, and then we can make an automatic rectification on the base of the daylight image. Maybe this is a mosaicing of 24 images, but it's not so much work like you think. We use our daylight image and we can mix automatically the rectification on the base of the daylight image. It's not difficult, it's easy. That means you can do this alone. It's an example, yes, daylight UV light. It's very easy to use our software for paintings, but how can I say, at the time we have no much customers for painting conservation. In the education and also in the museums, they think it's easy to open a Photoshop and take the image and to make some drawings. It's not so difficult like our software. If you open our software, you must speak about scales and resolutions, and you must make the rectification, and for a lot of people they say it's too much. I must think too much before, I cannot start. But I think in the training you will see it's need 5 minutes to prepare a project and then you can start. At time we have no idea how we can change this. It's very easy to make the rectification by a rectangle for this painting, and then you can make the rectification of the historic image, of the UV light image, and you can make the mapping in one project. I think it's a question of quality, yes, for documentation. It's not much working time. It's we use together with Asmus storyline. He have a mobile X-ray camera. And so we come to make the daylight and the UV light and infrared images, and he makes for us the X-ray images, so we can go to the church, to the altar, and makes this documentation for X-ray. These are examples of X-ray. Okay, now we speak about the evaluation of historic images. In Germany we have 3 large libraries. They collected historic photographs on glass plates from the time from, I think, 1880 until the Second World War. They have taken photographs with glass plates. 13 to 80 centimeter or 24 or 44 centimeters. And the idea is if I have only one image, you can make 2D image rectification, like with daylight images, no problem. And you can use the daylight images for the rectification. And if you have 2 or 3 images, then you can also make 3D evaluations. So you can, maybe you can measure some 3D coordinates for profile lines to make the reconstruction of dimensions for lost segments. Yes? And we have very large format of negative. If I have a negative 13 to 18 centimeter, I can scan this with 12,200 dpi. So I have resolution from 13,000 to 18,000 points with one class plate. It's much more than with a modern digital camera. And the class plate is stable, there's no changing. 50 years or 100 years, yes, it's a stable format. And it works with long focal lengths, so we have also no distortion. So for me, it's our perfect images, yes, for photogrammetry. And this is Albrecht Meidenbauer. He was strange for his time. He works with a camera with 40 to 40 centimeters on class plates. You must understand 40 to 40 centimeters, yes. This was his cameras, and he had a small car with a horse, yes, and he prepared the class plate on site, takes the photos and makes a development of the class plates. And he takes not only the nice view of the image, he makes a systematically, how can I say, documentation of the object from all sides. And so for me it's very interesting because I can, with these images, I can calculate 3D coordinates and the accuracy of 2 or 3 centimeters. It's possible, yes. This is the example of the class plate of Meidenbauer. You see the room, you see the detail, and you see the resolution of this detail. One class plate, it's very strange. This is an example for 2D. Maybe this is an image from the 90s. It was in the borderline between East and West Germany. That's why you can see this guy. And at first you take the image from today, and you can make the rectification by the width and the height of the room. It's easy to measure. And then you take the historical image, you measure connecting points, and so you can make the reconstruction of the lost parts. And then you can make the decision which elements you will make the reconstruction or not. This is an example for 3D. You see the church in 2013, I have used this in the last year. You see Meidenbauer class plates from different directions to the tower. And this part is construction from wooden and cover. It was burning down in the Second World War. And now they have collected money to make the reconstruction of this part of the tower. And there are 2 things. It's not only to get the information for a perfect reconstruction, it's also interesting to know the sides and to calculate, how can I say, how heavy, so you make not a wrong decision to destroy the first part of the tower. There are 2 things. You need the real information to make not more damages. Okay, this is the resolution of the Meidenbauer image. Yes, you see the detail. And this is the car. I think this is the car, the horse and the car. And now you see the direction of 2, 3 images, and I measure identical points in the images, and I can calculate coordinates. And the architect gets a list of coordinates in the first step. In the second step, I can make rectification by the knowledge of the position of the rectification plan. It's not necessary to measure 6 or 8 coordinates. It's enough if I have 2 coordinates, the left and the right. And then I can define the position of this plan. And then you see the rectification also. It's possible. And the next, it's more strange. I have calculated the height of this. And then I have defined the horizontal plane. Then you see the rectification of different images. And so I can calculate the horizontal section of this part. You understand? It's possible to play different images. Okay. It's very simply example. It's only a small church in the village. And they have lost all this, and they are interested to make the reconstruction of this small part of the painting. It's no much works. It's only one image, it's a postcard. And so I measure coordinates to calculate the orientation. I measure the position of the wall, and then we have make only 3 rectifications. For this segment, for this, yes, you see the details, and you see the unwrapping of this. And then the painter can come, can produce one-to-one, can put it to the wall and can repeat it. Okay, this was the first part about our work. We have some questions, or should I make the next?
I have a question, please. What about all the measurements? Do you do all the measures by hand, or does the program does all the measures like you need?
No, if we works, we measure by total station.
Okay, so you have to have that.
We have a total station, yes, we are surveyors, and I think it's not so expensive. Maybe today you can buy a total station for 10,000 euro.
All right.
It's a lot of money for a conservator, but in Germany you can rent the total station for 1 day. Maybe you pay 50 euro, yes. And in 1 day you can measure a lot of points at the total station. And I think it's cheaper than to measure 2 or 3 days distance as an object.
And is there like a minimum of measurements that you have to have in order to get like a perfect image? Or?
I will speak about this in the next presentation.
Okay.
So you can use the software only for rectifications by distances or by coordinates. And I'll show you some examples. Okay?
Okay. Cheers.
So, switch the how you can organize this if you try to get documentation or if you order documentation. In Germany we have a lot of different firms, a lot of different qualities, and it should help to find a decision. Okay, we speak about basic parameters, the resolution and the scale, which type of measuring data, and the camera sensor. We speak about the evaluation mode methods with 2D image or 3D auto and so on. About image montage and layout, and we speak about some of the library options. Okay, maybe this is an overview. How can I say? It's not a rule, yes, we have no rules for documentation. It's our experience after 15 years. For which projects we get which contracts to make the documentation, yes? And it's a little bit depending on the material. Maybe it's interesting for you to look to the conservation part, yes? If we work for stone conservators, we work normally in the scale 1 to 20, 1 to 25, normally, yes? It's a resolution of 1.5 millimeter. So you see all the problems in the stone. If the project is too large, or if the project is not so important, then we take also images in the scale 1 to 15, depending on how much money they have, and also depending on the work which they plan to do. Maybe if they will clean the windows, they don't need a plan 1 to 10. You understand? Yes, you must make the decisions. If we work for wall paintings, for mural paintings, we work in the field of 1 to 10, 1 to 20. A little bit depending on the size of the project. And sometimes we have, how can I say, important mural paintings from medieval time. Then we work also at the scale 1 to 5. But only for this. Yes. For Baroque objects, we work 1 to 10, 1 to 20. Then for wood, I think wood objects, maybe they are not so old, they are not so important. Sorry, it's maybe 100 years old, yes, or 150 years old. But they need the resolution to see the details. Maybe if you will see the joint between the wooden parts, you need 1 millimeter resolution and more to see the condition of this, yes? And that's why we work in this scale. Yes, in painting it's clear we need one-to-one normally. And so this makes the first decision. Yes, you see this table, you know this is a stone project or a mobile painting project, and so you can make the decision maybe category 1, 2, 3. A little bit depending on material and the importance of the project. And so it's very easy to find a decision. Yes, first step. You know this example from the first presentation. Now we speak about the types of rectifications. We speak about rectification by geometry, rectification by coordinates, and rectification usage of auto-projection of laser scanning and usage of CAD drawings. Yes, that means you have 4 options. And the first one is define a rectangle at the wall and to measure the width and the height. And for a small church in the village, nobody will come to us and pay money for this. The conservator has their own digital SLR camera, they take the images and they make a distro measurement to measure the distances, and they make the rectification alone. For small churches, we get no contracts, they do this alone. They have learned this, it's not difficult. And the problem is, it's not easy to find a rectangle as a project. It's more interesting to work with horizontal and vertical parallel lines. You can, maybe you find the line by the roof or the line of this architectural line, yes. You will find horizontal lines as an object. And if not, maybe you can measure the distances and you can define with markers the horizontal line. It's also possible, yes. And the vertical line, you can use architectural lines, or you can take a plumb line. You know what I mean, yes? You take this small plumb line. Mm-hmm. It's very easy, you need 5 minutes to take 2 plumb lines on the facade, you have a vertical line. If you need the accuracy, yes? And as we speak about the accuracy, maybe we measure the distance 1 to 2 centimeters. And the definition of geometry, I think you make a mistake between 2 and 5 centimeters. Depending on the quality of the object, yes. And we have old objects, and so they have deformations, and they have no vertical lines. It's clear. This is the first thing. If you have small objects, maybe paintings or small fragments or a mosaic, you can use the same functions. We have the rectangle. Sometimes the people don't use the information of the object. Maybe they have a plate and they mark a grid cross on the plate, and then they take the object and they use the information of the grid crosses to make the rectification. So it's not necessary to measure. Yes? For painting it's easy to measure this. And maybe you are in the church and you have a small fragment of a mural painting, and around this wide area. And then you define 4 points and you measure 6 distances. And so we can calculate the rectangle by the diagonal lines. It's 5 minutes more work, but you have a stable rectification. And the accuracy, maybe in this detail, you can measure distances 1 to 2 millimeters. And the mistake by geometry, I say maybe 2 or 5 millimeters. So you have good quality for this. For small objects, you can work in high quality alone. You don't need support. Yes. This is our work. We take the image and we measure coordinates. The quality of the coordinates is 5 to 10 millimeters. And if you take the rectangle, you have no control for the rectangle. If we measure coordinates, if we have more than 4 coordinates, then we can calculate the mistake for the rectification. The error. That means every time I have control about my result. The software will show me which point has which error. Then I can switch off the point, or I can look for the mistake. Maybe I have measured the wrong edge of the stone. Yes. So we have every time control. And the next advantage, if I need 2 images, by the rectification by coordinate, every image knows the position on the large image plane by usage of the coordinates. And so I measure the coordinates and automatically the image goes to the right position. If you make the rectification by rectangle, you must move them presently identical points, and you make more mistakes. And if you do not find the vertical lines, so you have some problems in the overlaying area between the images. Because in the left image, maybe you have to make a small mistake 2 millimeters to the left and 2 millimeters to the right. And so you have problems by making mosaicing of large image plans. That means if you work with single images, it's very easy to work with distances. And if you have mosaicings of 4, 5, 6 images and more, please take a surveyor and they come one day to me and measure coordinates. And the rectification you can do alone. Yes? If you have laser scanning data, you can say, please give me the auto projection. And you see this image from before, from the presentation before. Now you search identical points to the image. Maybe sometimes you have problems in the identification of the natural points because it don't look nice as the laser scanning data. But now you have the correct position of the images. And you have more support by the mosaicing of large image plans. And if you take every time the same point in the overlapping area, so you have no problems in the overlapping. I think it helps. If you have laser scanning data, you say, okay, it's not fine, but you can use it. You must take this part which you need. And if you have a CAD drawing, we must make the decision about the accuracy of the CAD drawing. We have 3 types of CAD drawings. The first one, it is a surveying by total station. And so we have the same quality by the control points. But the problem is, if I measure control points, then I take special edges, special points, which I can good identify in the image and in the object. If you measure a CAD drawing like this, maybe I can take this edge of this window, but maybe if you look in the image, it's not a clear edge, it's a round edge. And so you have some problems by identifying the points. That's why the accuracy is not the same, yes? Okay, if you have a plan by total station, you have, I think it's enough for 120, 150 and so on, yes? If you work with photogrammetric stereo evaluation, I think the plans maybe they are 20 or 30 years old, you have a large paper plan, you must scan this paper plan. I think they have a good accuracy, but I say 2 to 5 centimeters. It's 20 years old, yes, the technology is 20 years old, so you cannot compare this with today. And if you work with a drawing by architects, I say 5 to 10 centimeters, it's depending on the drawing, you can test it. Sometimes it's a good idea to make an overview image of the object, and you take the 4 edges around the object, then you make the rectification. And then you can control the position of the windows of the drawing. And then you get a feeling, is it only a painting, or is it a good drawing? It helps to understand the quality of the drawings, yes? That's my opinion, yes? You make the difference between single image rectification. You can work with geometry, I think 2 millimeters, yes, 5 millimeters, 1 centimeters. If the people come and ask me for the accuracy of the plan, then I say you can measure the half millimeter in the plan printed out. That means you can take this half millimeter, multiply it with the scale, and so you have the quality which we try to get. That means 1 to 100 is 5 centimeters. Nobody comes to us to order a plan 1 to 100. You can do this alone. In 5 centimeters you can measure distances, you don't need a total station, yes? 1 to 50 for large plans, maybe the house is 100, 200 meters long. It's interesting to work with coordinates to get this result, 2.5 centimeters, yes? For stone conservators, 1 to 20, 1 centimeters. And now I have shown you by geometry, it's a little bit depending on the size of the project. If it is too large, you cannot reach this accuracy, yes? For smaller projects, it's easy. By total station, we have a problem. We have the optic, the objective of the total station with how can I say, this factor of 30. If I look through the object, I have the increasing of 30. That means I have a high quality of the detail looking through the objective of the tool station. And then I take the image and I never see this quality. And so sometimes we measure points which you cannot find the same quality in the image. And so in the scale 1 to 2, 1 to 5, we work with matching functions of Metigo MAP. That means if you have a painting, we make the rectification sometimes only by rectangle or by 6 coordinates for the overview image. And then the high resolution 1 to 1, 1 to 2, we make only the rectification by matching functions. Matching functions means the software search automatically identical points and the quality of subpixel, 0.2, 0.3 pixel in the image, yes. So it works with an area of 13 to 30 pixels to match the points. And so it's very easy to make the mosaicing of this image. For this high resolution, that's why I have this line, yes. For this high resolution, we work with matching functions. It's only interesting for if you have a real plan. A large memorial painting or a painting. Yes? It's not for architectural objects. Okay, if you work with point cloud, it's only 1 to 50, 1 to 100, not more. Maybe 1 to 20. In CAD drawings, I make the definition of surveying or stereophotogrammetry of architects, and maybe you can work 1 to 20, 1 to 10, but by architects 1 to 50, 1 to 100. Okay, and if you work with rectification and montage to get a large image plan, then you must stop by 1 to 10, 1 to 20 with measurement of distances. You need coordinates, or you need matching functions that you say, okay, I make an overview image of one. If it is possible to take one image, then you can say, I make detailed images to make by matching functions. In the training you will see this, I have examples of this. Okay, now we speak about the decision 2D image rectification or 3D auto projection. The reality is, I think, 80% we work in 2D with only 2D image rectification. And in the segment of mural paintings, we mix 90% of our 3D auto projections for ceilings, yes, and for curved surfaces. In this area, we mix the mean work with 3D auto projections. If we work on a facet for stone conservators, we mix 2D image rectification, not more. You can compare this, yes. Okay, 2D image rectification, we have only one plane on the surface. In 3D auto projection, we use for multiple curved surfaces or for heavy structure objects. And if I'm really interested to get a mosaicing with a lot of images. If you have a lot of structure at the object, it's also difficult to make a mosaicing, yes? In the next step, for image rectification, I need geometry or control points, and I need photographs with high resolution. For auto projection, I think at the beginning I need the same control points, only control points, because I need the control points for the photogrammetric orientation of the images. I cannot calculate the orientation by distances. I need the 3D coordinates. We take the same photos for auto projection, and then we need, and this is depending on the size of the project. In Germany, I must pay 3,000 or 4,000 euro depending on the size of the object to get a ready surface model. That means 1 or 2 persons come, they make the scanning of the ceiling of the church, maybe 1 day or 2 days, and they calculate the orientation, they calculate the triangulation. I need the surface like triangulation, not only the point cloud, and then I use it. I measure the control points for them that I know they calculate the scanning data in the same coordinate system like my image orientation. It's important. We can calculate the surface model also on digital stereophotogrammetry or for structure for motion. It's also possible, like Archisoft or 123CAD. Normally, they have the same bad quality like scanning data. For a lot of universities, it's easy to take 50 or 100 images, and they are happy if they have a rotating object in the website. but it's not good enough for documentation and conservation. Sometimes I use the surface model, but normally, for me, it's cheaper to take data by scanning. Okay, and for the scale 1 to 1 until 1 to 10, it's not possible, it's today not possible, to work with the result of today of laser scanning data. It's not good enough. Normally I say 1 to 20, not more, for auto projections. Okay, in this relation I say I have costs 1 to 3 for 2D image rectification or 3D auto projections. So the quality, the 2D image rectification, every time I have a high quality and it's very easy to, you can do this at all. For 3D auto projection, the quality is connected with the quality of the surface model. Sometimes you have round edges with mistakes of 1 or 2 centimeters, and then I come with an image with a resolution of 0.5 millimeter. And you see these problems in the image. And it's important to know before. And for the field of conservation of stone, yes, rectification to a medium plane is enough. For small objects, they can do this alone, they have no costs. And the disadvantage, it's clear, it's only one plane, and you have perspective effects. But in the stone conservation in Germany, if you have 3D objects, you must go to the object and you must measure the profile line by hand, 1 to 1. If you try to maybe to reproduce a profile line. You cannot take the orthophoto, you cannot take the image plan, it's not good enough. You cannot measure in a plan 1 to 20 or 1 to 25 a reconstruction of the profile line, you must do this as an object. And that's why you don't need auto projection in the area of stone conservation. Okay. So this is, I have writes this, you can read it. So I can drink water. Okay. Some short examples, you know this example, I can go to the next, yes? I have also seen this. Go to the next, you have seen this also already, go to the next. Now we speak about mosaicing of the images. It's necessary if you order the image frame that you say, okay, it's not enough to make the rectification of the single images. You must make the mosaicing in Adobe Photoshop or maybe GIMP, so that you get a color correction and that you have no differences in the overlaying area of the images. Sometimes you have a deformation in the walls and you go to Adobe Photoshop and make small corrections in Adobe Photoshop. It's not every time a correct result depending on the surface of the object. Yes. And we speak about the layout. Normally we say you need the grid courses and you need the scale bar in the layout. You need both. Because you have problems. Some people take the images, they make the changing of the resolution, or by printing out in PDF file, they make adapt to paper size, and so you have a wrong scale in the image. And if you have the crosses, you can control the scale in 2 directions. If you have only the scale bar, so you can only control in 1 direction. And that normally for photogrammetry we use crosses around. And if you use the mapping software, you need 2 minutes to define the crosses, not more. For us, it's a documentation of the scale. 10 years later, someone gets this image, who can control the size. And then you can start with the mapping. Yes. Some people take the image, make the mapping of 3D, and then they call us the image is wrong. How can we change it? Yes, at the beginning they save 5 or 10 minutes working time, and later they speak about 3 days and more. Okay, we speak about file formats. We use since 1990, we work with TIFF. Okay, but at the beginning we speak with RAW, with RAW. Normally, in my opinion, with the RAW format in our office, they were developed by the photograph. he has the information of the situation on site. He take a developing program, he knows on which place he have used the clay card or the color card, and he knows some problems with the light. And on this information, he makes the development of the images and saves the files as in TIFF file. And then we have a stable format for rectification and so on. If I give the raw file to the customer, maybe for the archive, I think in 10 or 20 years he cannot use it. He has not the information, and raw is it in dynamically format. Nobody knows in 10 years there are so much changes for cameras, maybe they cannot read the old formats. So it's only, I think it's interesting for a short time today, if the customer say, I need the original raw file, so we can control the work of the surveyor. We can control the resolution of the original images, so there is not too much scaling on the sides of the images. It's interesting for you that you can control the work. I think it's important to say you will have the original image files. Okay, the next step, we speak about the image formats. We work with TIFF. We have the LZB compression, and it's with no loss of information by compression. And I know this format since 30 years. It's open, you can use libraries, and everyone can develop software with TIFF libraries. If we speak about PNG, they have made some, how can I say, they have adapted this format for good usage for the hardware, for monitors and so on. So it's a little bit reduced, and they have no CM by K for printing out by analog, yes, it's important, yes. And so normally we do not use this, we use TIFF. And JPEG, it's terrible. I mix a lot of education and universities. And I come to the students, and as they show me the examples, we make trainings with rectification, and they come with a camera, and they give me a list of JPEG files, and I do not understand why, yes? Every time if you save a JPEG file, you have a new compression. And every time you have a new loss of information of compression. It's so easy to understand. You can take a photo maybe from a painting, and you can save it 10 times, and you can see the development. It's 10 minutes education in the documentation education, yes? I think the students should understand this. Okay, it's, you can use a high compression of JPEG, and so you can send a mail file for, how can I say, for communication, for working process, that's clear, but not for documentation. This is also a nice joke. You get a lot of 30 minutes, yes? So it's okay. We get a lot of requests that the people say image plane have to be delivered in drawing format, in CAD format. It's wrong, yes? Because the CAD file saves only the connection to the image file and saves the information of position and scale, not more. The image file is by side. No CAD file integrates the image data in the CAD file. It's not necessary. The image is on the... And so you can, if you lost the CAD file because the people 5 or 10 years later have not the CAD system to work with this CAD file, they have only a stable of image files, and they have not the information about scaling, positioning, and so on. And so at first you must say, the images have to be rectified and mounted and color balanced to one image plane. And in the second step you can say, the image plane have to be georeferenced in CAD file. And then you have only one images, and maybe if you have no CAD file, you have the crosses and the scale bar, and you can correct it alone. That's important. You need a navigation map, so that you see all the images. Normally, it would be fine, I say this, if the customer come to me, give me the navigation map and say, this is the work, please calculate the price. But I never get this, yes? Normally, it's the result of our work. And we must go out and we must calculate the work, and then he gets this plan. But to make, and how can I say, he asked 2 or 3 firms for the price. And I think if we make a good contest to get the best price, I must do some things before. It's not, I cannot take the cheapest, he have lost a lot of information because he have only calculated the half part of the work. Then you give money and you have only the half part of the work. Okay, this is the conclusions for you. How large is my budget? What is the time schedule? If the time schedule is very short, I must look for the size of the firm, if they can do this job in the short time, yes. Which level of details, it means which scale and resolution, depending on the project, and so on. Which camera is being used, yes, how control measurement, and the resolution of the scale of the product, and some technical information. That's all. This was the second presentation. Now I have 30 minutes for Metigo MAP. I have control over my time. I close this. And now I speak Metigo MAP. So, that's it. If we speak about Metigo MAP, the first license we sell in 1999. That means the software now 16, 17 years, yes? And in this time, we worked together with our customers for documentation. And so we have collected ideas from our customers in the time of 16 years. That means all the functions for image rectification, this is our own work, these are our ideas. But all the functions for mapping and evaluation and cost calculation and so on, these are the ideas from our customer. And so you can find a lot of ideas in this program. Sometimes you must only ask if it is possible. And then you say, yes, it's possible, on this edge or on this edge, yes. There are a lot of functions in this program. And so I speak about 4 parts. I speak about documentation true to scale. These are the functions for rectification and so on. We speak about vector-based mapping, like in CAD. We speak about the data and the area analysis, and we speak about quantity and cost calculation. Okay, we start with rectification. In the first step, you can start with a ready documentation. Maybe you have all of this. That means you can import large image files by TIFF or by BMP. We have a lot of file formats. You can import CAD files, drawing files, and DXF files. And you can take all paper planes, you scan the paper plane, and you make the escalation maybe to the scale bar. Or you go out and measure 1 distances, and you scale the paper plane to 1 distance. It's very easy to use. If you have no documentation, you must work alone. At first, with 2D image rectification by geometry. We have speak about the rectangles, the parallel lines, and the distance net. And if you have only small 3D objects, you cannot use the rectification. You go around, you make 4 or 6 or 8 images, and you make also only the scaling by the height. It's easy to measure by the height, and so you can put the images together and make the mapping nearly to 1 scale. You need 10 minutes to make 4 or 6 scalations and put them together, and you can start to work. Okay, image rectification by coordinate. It's interesting if you have already this plan, then you can measure points at this plan, you take your image and you make rectification. Or you can order this plan. This is an example for rectification. You have this wall and you have the images. And you see it's not good to see the coordinates, and you see the result. You can do this alone, you define only the rectangle, measure the width and the height, and then get the rectification. You have seen this before? This is an example for the automatically rectification of details. It means you load the detail image, and you must define the area for the searching of connecting points. We need this area that we can calculate the scale between the 2 images. It's important for the matching functions. And then we start and try to get the points. And sometimes, how can I say, the matching functions work in the grayscale image. It's not a problem if you have some mistakes in the color, or if you have a historic image, it works. You can also use UV light images, it works too. But you cannot work with X-ray image, it's not possible, and also with infrared, because the structure of the grayscale is changed by the filter of the spectral lamp. Yes? That means X-ray or infrared, you must measure your own points. And sometimes we have problems for too much changes on the painting, it's possible, yes. And then you must search by manual measurement for points. Yes. And if we measure the coordinates automatically, then we know the position of the image. It's automatic. Yes. It's a very easy example. You see a small church, you measure the distance of the width and the height, you make the rectification of the first image. And then you take the images with a higher resolution and for every window, yes? And you see the red points, we have found all these points, and we take for every square 1 point for the rectification. The first image, 5 images, you make the multi-layer TIFF export to Adobe Photoshop, you make the color correction. It's very easy. Maybe you need a little bit training. It's more important to take good photographs. Rectification, you can learn this. We have a function for distortion correction. That means this is our training room. If you come to Leipzig, you can come with your camera. Or you take one wall of your institute. You can download this chest plate as a TIFF file on our website. And then you print it out, and you can put it on the wall. And then you take one image. And then you see we use the chest plate to calculate the distortion of the lens. And for every lens, we save the parameters of distortion. And then you have a list of cameras with different lenses, and you go out, take the photos, and come back and say, today I have used Canon 5D 24 millimeters, and make the distortion correction before rectification. It's important. You must make the correction before. It's an example for thermographic. So you have 2 infrared heating lamps. You see the wall paintings, the medieval wall painting. And they have a small camera and small infrared camera. And they have heat the surface. Not much, only 2 or 3 degrees. Normally in summer you have more changing in summertime in the church. They do this in wintertime if the wall is cold. And at first they make the rectification of the daylight image, and then they use small control points with a little bit cool, maybe it's a temperature of 10 degrees, that you can find the points in the infrared image, yes? And so you can, maybe every 30 seconds you take the image, the next, and the next, and the next. And now you see the places where the heating from the lamps is, how can I say, collecting on the wall. If they have a good connection to the wall, the heating is going in the wall. Or if you have a changing of material, maybe a wooden part or steel, yes, it's going away. And so you can analyze maybe the parts of the painting who have lost the connection to the wall. Or a changing of material, yes? And you see, these are only 2 degrees, not more, 2.5. It's possible. We have prepared for 3D mapping, but at the time it's not the reality. Now we speak about the mapping, the vector-based mapping. That means we have mixed rectification to the image. We know the scale of the image. And we scale all lines, all points which you measure on the images, we scale to the scale 1 to 1. That means inside of the project we save the coordinates in the scale 1 to 1, like in a CAD system. And on this base we can calculate the area, the length of the lines, and so on. That means you can combine images with different scales. It's possible. Maybe you have a historic image scale 1 to 100, and you have a documentation of detail maybe 1 to 20. You can combine these images in one method. We scale them to the project size. And we have a lot of drawing tools like in CAD system, polygon, freehand lines, circles, 3-point, and cubic spline. We have function for cutting lines, cutting areas, and so on. And during the mapping, automatically for every element we calculate the area, the circumstance, or by the line you calculate the length. You do this automatically in the background. You can switch it off or you can switch it on. This is the class management. It's look like the layer management in CAD. Yes. You have a special thing. If you create a new class for mapping, you must make the decision, is it an area mapping class or is it a line mapping class? Or is it a class for annotations or for symbols? It means you cannot combine different elements in one class. At the beginning we get the question why, and at the end you understand, because we have clear classes, only with areas, only with lines, you can get a clear report. How many elements, how many spaces, how many elements, how many meters. Every element has the same color and the same hatching like in the class definition. In AutoCAD every element can get a new color. But you cannot change automatically altogether. You have programs to change the colors and it's new working time. And so we have in the class management you can change colors, hatchings, and automatically we go to the mapping and change all elements of this class. So you have the same viewing like in the class management. And you can define much more information. Every class can get his own data fields. Maybe you make the area mapping, you give the information for the deep, and so we calculate the volume. Or special informations about the accuracy, how many sites is hinter the point, yes? Hinter the point. Okay, we have a group management. If you have a large project with classes for material, for damages, and for documentation of the work, you can define groups. So you can maybe 20 or 50 groups, you have free choice. You can create different combinations of damages, of materials, and so on. It's very easy. You need 1 minute or 2 minutes to define a group. You create the name, you select some classes from the project, and then you can say, please show me this group, or the next group, or the next group. And so you can learn to understand the combination of different types of damages with the material and so on. Okay, you see the legend. The legend is connected with the class management. That means these are the hatchings and the colors and the name of the class. If you change the class management, we change automatically the legend. And if you switch it on, then you can see how many elements or how many kilometers. If you switch it off, you don't see this. Sometimes you need this and sometimes not. At the beginning, I say you must start with a small project to understand how the program works. And later you can work with large projects. We have a hierarchy. That means we have one mapping template. Here you can define the classes, the colors, the hatchings, and the units, and so on. And all the other projects are connected with this template. And if you make some changes, you can say adapt to all projects, and automatically all projects have the same viewing like the template. You can create this navigation card. It's for good working, I can say. You can define the position of the projects. You can select the project, you see the overview. In the next step, we use these link areas to show the content of the project. Maybe you have defined the mapping area and we calculate for every project maybe how many percent related to the mapping area in this project. So you can combine the intensity of special damages for this project. And you can select one type of damage, and you see the different type of colors. And so you can try to understand why we have in the north or in the south or in the west more damages of this type, yes? And we do this automatically. You have to make the mapping. You must understand, if you make a mapping in Adobe Photoshop, you have a colored image. If you make mapping in CAD, you have the same. And we say we have this mapping and we use it for evaluation. You can do more with this. It's not only a colored image. Okay, the is the example for stone conservation. Yes, you can go to the hierarchy, you select one class, then we give you the list over all projects, how many pieces in the class, and how many elements together over the whole project. And so they have control about the costs during the work. One day in the week, someone goes out with a tablet PC and makes documentation of the work of this week. And so on Friday he can say how many we have done. And he can calculate the invoice and so on. Yes, you can do this. Now we speak about data and area analysis. We have user management. It's nice to speak about this. We save since version 4. For every element, we save the date of creation, and the date of the last changing. And we save the user who creates the element, and the user who makes the last changing. And normally we think it's a good thing. Maybe you have a painting, every year so you have 2, 3 or 4 exhibitions, and you have a condition report, and so you can ask who makes the mapping of this damage, and you can ask him about the reason and so on. Or maybe you have a large stone facet, you can analyze which mappings on which week, so you have control about the development of the cost of this project. But normally the conservators don't use these functions. They like to make the mapping anonym, I can say anonym, yes. But if they write the invoice, they write the name on the invoice, yes. But for the mapping, not. It's very easy, you can create 3, 4, 5 users, and every time if you open the project, you ask which user. And you can switch the users, and you can also define different rights to the user. That means you can say every user can change and delete his own elements, but you can protect the elements of the other users. And so maybe the first conservator makes the report of the condition. And the next conservator, who is responsible for the costs, he makes the plan of the work. And so he cannot change the condition, because he says it's too expensive, some things we have apart. And the third conservator makes the documentation of the work. He cannot change the planning of the work. You understand? It's very easy. Okay, user management. We have in data analysis of mapping, maybe the simple thing is you can take one mapping class, you can define a special group depending on the size of the elements, because for small areas you have another cost calculation like for large areas. For large areas you need more material, for small areas you need more working time. And you can switch on and you see the result, and then you can copy this to different classes. We have an area analysis. In Germany we have some special cathedrals, and they have made drawings with the stones, and every stone has a number, that means every stone has a name. And so they try to make the documentation of the conservation history of every stone. I think it's too much money, too much work. And maybe they do this 5 or 10 years, and later they will finish this, I'm sure. And they have, how can I say, burn a lot of money, yes. And so we have developed this function, and maybe if you makes the drawing of the stones, you can make the mapping. It's not necessary to connect the information to every stone. And we make only the analyzing of the overlapping area. That means you can select one class, maybe quarter, and then you can select some damages. Then you can say, analyze, please show me all stones with the material limestone and the overlapping with a special type of damage, so that you can find the places where you must do some work. And now you must think, how can I say, you must write the horizon. Now you draw no stones. Maybe you say, I have a scaffolding, and for the first and for the second and the third floor of the scaffolding, you draw one rectangle. And so you can ask how many material, how many work I need for every plan of the scaffolding. So you can organize the work. Yes. The next example is, maybe you have to make a mapping of materials of different stone types on the facade. So you have to make some changes, so you have different stones. And so you use the different types of materials to analyze on which type of material I have special combinations of damages. So you select at first material A and say, please show me all stones of this material with this special type of damage. And so you can analyze the condition. Yes? You have the function of the program, and you must learn to define the question. Yes, you must understand this. It's like an GIS, Graphic Information System. Okay, so this is the result, and the result is the mapping, and so on. Now we speak about quantity and cost calculation. Germans are very organized, and so we have a lot of control about cost calculation. This is a special German interface for exchange of costs information by large projects. That means before they start to build a building, one architect defines the parameters, maybe how many stones and how many working time and so on, and they create the SCAD file. And then they send the SCAD file to 5, 10, 20 firms, and the firms must write the prices for material and working time in the SCAD file. And then he collects these files together. We have, I think, over 20 different software development firms who produce software programs for this SCAD file. It's a very large marketplace. And they earn a lot of money. And then he can compare the cost calculations by material, by working time, and can think about what is the best solution for our project. Maybe if it is a long project over 5 years, he must think about changing the cost of materials. Yes, if it's only a short period with not much material, then you can look for the working time. So we use the SCAD file. That means you can import the SCAD file, and then you can make the mapping in the position of the SCAD file. That means the firm makes the cost calculation, they have to get the contract, he imports the position of the SCAD file, and they make the documentation of the work in the position of the SCAD file. And so they can write the invoices or mapping and the layout of the SCAD file. For every element, we save an index. This is the name for every element, yes, 1, 2, 3, 4. And you cannot change this number. That means in every mapping class, maybe stone exchange, we count all elements, and if you delete number 11 will never come back. The next is number 12, number 13. And so every element is a fixed position in the calculation of the cost for the invoice. And we have different types for calculation of area mapping. Maybe you draw a polyline, and we use a polyline for calculation. The next one is we calculate the smallest rectangle around this polyline. Because people say it's a nice polyline, I never can control this area. I have not the possibility to control this area. So they say, you take the smallest rectangle around, you can measure the length and the height, so you can calculate the area at all. And the third step is the people make control measurements by hand, by manual measurements. You go out and measure the wide, the high, and the deep. And they make the protocol. You have this dialog, you can write these measurements, and you can export to a Microsoft Excel file. You see the index numbers, you see the measurements, and you can calculate the cost. It looks like a lot of work, but if you how can I say, if you have a good organization of the data in the program, it's not much work. Other people take paper and count the elements and sort them, and if they must change it, they start again. Yes, sitting in CAD and draw and count the elements on the surface. Yes. And the last development is, how can I say, a cost calculation, a module for cost calculation. It's interesting for stone conservators, yes? In the first step, you can define special information for working time. You have different types of qualifications on the project. And so you have different cost calculations for 1 hour or by minutes, yes? Then you can define the costs by material, and then you can define the costs by equipment. And then you select one mapping class, maybe stone exchange, and you can say, I need 3 steps for working time. I go to the project, I must cut the stone. Then I go down and I must prepare the new stone, and then I go back and must put the new stone in the wall. 3 steps. Then you must calculate the material, the stone, depending on the size of the mapping, yes. And maybe you need a little bit line to integrate this in the wall again. And then you need equipment to cut the stone in the wall and to prepare the new stone. And then you make the mapping, maybe for 5, 6 elements, and we automatically calculate the costs for material, for working time, and for the usage of the equipment. You do this automatically. You make the mapping for the documentation. And it's not to prepare the offer. I think it's good to understand after the documentation project. You have finalized the project, you have to do a lot of work, and you must do the documentation of the work. As in Germany, you must do this. I think here also. That means you make the mapping. And now you have defined for one time the parameters of the costs for your firm. So you can every time after the project look of the information, how many working time I have need, and how many working time I have calculated before. And you can learn to understand the costs of your firm. The mean work is the mapping. You must do this in the Photoshop, in AutoCAD, or in our software. But the result of the information is more. You must learn to understand this. And you must learn to, how can I say, to use this information for your own work. And no conservator uses all the functions in this program. Everyone must select the special functions which you need. Yes? No use all. And there are too much functions. Developed in 16 years, and these are not our ideas. Okay. I have finished the time, correct or not? Thank you. You have questions? You have some questions or not? Too much information?
Quite a lot of numbers.
I think a lot of people come to the trainings in the next days. Yes, all of them, yes? Yes. I think for me it's very interesting if you bring some images of your own work, so you can speak about this. For the training I had some German projects, maybe it's nice to see some German objects. But I think it's very interesting if you give me on a USB stick some examples, and then I can look at the images and I can show you some things how you can work with this. Yes?
Are there some specifications for the images we can bring, like a format, and do you need measurements or?
Yes, I think at the beginning you come only with the images for the first day, and we speak about this, and next week we will see again. And so you have time with the knowledge of the first training day to take the images, to make your own measurement, and to make your own rectifications without me. And next week, Thursday and Friday, we can speak about this. We can speak about the problems and so on. And so I think it's a good good organization. That you make the training, you have time to test it, and 1 week later we see again. I think that's good. Okay, next question. I accept JPEG and TIFF files for the training, it's no problem. No raw files, I cannot read raw files on Metigo MAP.
Can you wear the microphone?
Pues primero, en primer lugar, agradecer la plática del día de hoy. Pues ya nos seguiremos viendo para adentrarnos en este programa. Pero sí, tenía la duda si necesitamos como conocimientos previos para poder manejar el software. Es decir, vemos que hay todo un tema de fotogrametría que tiene que ver obviamente con toda la teoría y práctica en el tema. También el tema de dibujo, el dibujo arquitectónico, que bueno, al parecer en las pantallas es muy parecido al CAD, pero tendrá también sus diferencias. Y bueno, y por supuesto ya todo este último módulo de costos y cantidades, ¿no? Entonces, pues a ver si alguien que no tiene a lo mejor las nociones de estos 3 módulos, vamos a estar en condiciones de aprender a usar el software, o es un software tan noble que que sin tener esos conocimientos vamos a poder utilizarlo, pues obviamente con práctica, pero pues sí tenemos esperanza de aprender a usarlo pues en estos días.
There are different things, yes? At the beginning, it's clear you must start with simple projects. It's normally you must learn to get a feeling how you can make simple rectification and how you can organize a small project. And for these steps, we have tutorials on our website. And we have trainings examples. You get these trainings examples in the next days. And so you can look at tutorials and you can make these steps also alone. It's possible. For the future, I think maybe you know Jacinta. I think in winter time she comes to Mexico. Jacinta? You know Jacinta? Jacinta, yes. I think she was. And I think she comes every winter time to Mexico, and summertime she works in. And so you have, I think, a continue and support. And for me, I think it's a little bit depending on the interest to our software. If I come back maybe 1 time or every 2 years, yes. And I think it's also a question for universities. I think there are a lot. They should have teachers who learn to work with our program. And German conservators are also no specialists in digital mapping, as they start to learn by 0. Yes, I think it's not difficult. At the beginning, you are a little bit afraid about so much functions. But it's wrong to think about so much functions. At the beginning, you must say, which I need for my own work in the first steps. And then with every project, you learn to do more. You understand more and you do more. It's a process of development. And it's no good idea to start with a large project. Because if you work on a large project, you have a lot of you have a lot of problems with a large project, and you have no time to learn the mapping software. And so at first, sometimes I say to the people, please take the mapping from the last year and repeat it. And so the head is free to concentrate to the mapping. Yes? And so you must be careful at the beginning, step by step. You have studied your things, you have enough information in your head. Use the program. I think so.
Muchas gracias. Por lo que yo puedo entender en la presentación, el software combina las virtudes de los programas de imágenes raster con las de los programas que procesan información de vectores. Al principio tenemos que alimentar al programa de una imagen raster controlada en el sentido de la resolución y una escala. El programa controla una escala y genera los mapas y genera los mosaicos. Y ya sobre esta imagen hay la oportunidad de dibujar vectores y el programa nos entrega cuantificación del tamaño de estos vectores. Bien, ahora en algunos materiales en el tema de la conservación del patrimonio, los objetos a analizar tienen formas orgánicas. ¿Cómo es que se puede hacer este tipo de dibujos en el software? Sí, que no tienen formas geométricas de polilíneas, sino totalmente orgánicas. Por ejemplo, una grieta es una forma difícil de dibujar en el sentido de dibujarla con vectores. O cuando se pierde una parte del aplanado o una parte de la capa pictórica, no necesariamente esto se puede englobar en una forma geométrica, sino la forma es orgánica. Entonces el dibujo debiera de ser a mano alzada. O sea, hay la posibilidad de conectar al programa una tableta, por ejemplo, y dibujar sobre la tableta. Esa sería la pregunta. Y por supuesto, si el programa puede calcular la forma orgánica, ¿no? El área de la forma orgánica.
Ahí está tu grieta.
You must find a compromise for the users, that you have spline functions. You have also functions for a freehand line. Yes, I follow the line. If I select the spline functions, I can correct the points. Yes? If I select the freehand line, it's like in Adobe Photoshop. It makes no sense to change the surface. Yes? So you have a polyline function, yes, and you can combine these line types, yes. That means I start with a polyline. It's okay. It's a process of learning, it's clear.
Hola, ¿es compatible Metigo con programas? ¿Es compatible Metigo con programas BIM como Revit?
You can write the mapping in a CAD format, like DXF drawing file format, yes. But you have not all information about the mass calculation and so on in this drawing export. It means Sometimes in Germany we have projects where the conservator must give the mapping in a CAD format. That means you make the mapping, you finish the mapping, and you can do project, export, CAD drawing DXF. You can select the classes which you are interested, and you can select maybe the type of the AutoCAD format, and you can write out. Yes. But it's not, it's only one way. Because by writing export we lost some information, so we cannot change in CAD and come back, and it's not possible. You can import also all CAD drawings. We analyze the classes and say, okay, this is a class by area mapping, and you can import CAD mappings. To continue the work, yes. But you cannot mix dynamically exchange. Maybe if you work with CAD, you can use rectification functions. You make rectification, and then you make the export of the rectified image to a drawing file, and then you can make the drawing in CAD. Possible.
I have a question about how do you do the first or the initial mapping? In terms of let's say this, I have the photographs, I have a very good resolution photographs, and then I have an AutoCAD drawings, but I don't have the demonstration points of all these, let's say, this element that I want to map. So may I start with using the photographs and the AutoCAD drawing, and then later I can integrate all the total station points once I take them? Or does this have an impact or an influence into the scale and the resolution that I want to get, which is 1 to 10 or 1 to 5?
I say you have free choice. For me, yes, if I would do this, I would measure at first the coordinates my total station and make rectification, because for me it's the highest accuracy. Do you understand?
Yeah.
But you can also take at first the CAD drawing, because you have not asked. This is the only way for you, so you make the import of the CAD file. Maybe you see the project tree, and you can import image files, you can import CAD files, yes?
But what I mean is, if we do have this information already, and then is it possible later to integrate what we need, which is in this case for the rectification?
There's a small problem. You use the CAD file with some mistakes, and you make the rectification. And then you make the mappings. Maybe you can change later the images, but the mappings is on the position. Do you understand? On the first images. And so I think maybe if the CAD file is good enough, then you use this step.
So what is good enough?
What is good enough, yes.
Yeah, that's the question, because...
I do not know your CAD file.
Yeah, well, I don't know, I have to take a look and see, but if it's good resolution, it's, I don't know how to say it, I don't know exactly, but I can find out. I'll find out.
But you can test it. I have told you the example, yes. If you use the CAD file, and you take the overview image, maybe for a larger part, and then you can look how it works together. It's very easy to show the mistakes on the architect drawing. You can bring the example in the next place, you can speak about it.
Yeah, no, I'll have it, yeah. I'm ready. When almost now.
Es una pregunta muy veloz. En el caso de las nubes de puntos del escáner láser, el programa lo lee como imagen o sí que lee como un modelo tridimensional.
Two ways. If you are interested to make the mapping on a 3D surface file, then you can import the 3D object, like the format STL or VML. STL is a grayscale surface and VML is a surface with colors.
La segunda es una superficie de colores.
Just look to me, but wait a moment, I switch to English, language English. Since 1 week we have the Spanish version. And I go to surface model, and I can say, you can read this. You can make surface model, I can select the file, and then I can work with STL file or PTS or VML. We have some formats for surface model, yes. And you can use the surface model to calculate an auto projection. So you can also make in Metigo mapping an auto projection. That's one way. And the second way is maybe some architect office makes a laser scanning. So you can say, please don't take the point clouds with all the problems. Ask for the auto projection of the point clouds. And so you get a TIFF file. And so you can load the TIFF file with scale and you use it to measure points for your own rectification. That means you can import 3D surface models and can calculate the auto projection, or you can make the mapping on 3D surface. But I think at time it's too heavy by the data. And it's more interesting to take the auto projection, measure coordinates, take your own image in your resolution which you need, and make some new rectifications. I think it's, in my opinion, the best compromise.
Bueno, pues muchas gracias.
Muchas gracias por su presencia el día de hoy. Si alguien tiene dudas acerca del grupo que le ha tocado, los 50 participantes que estamos aquí vamos a estar divididos en 4 grupos de 12 o 13 personas. En la invitación ustedes recibieron qué días son los que tienen que estar presentes. No es necesario que traigan equipo, ya que las máquinas ya están en la sala de consejo del ENCRIM, ya tienen el programa cargado, tenemos los nombres listos, entonces ustedes solamente tienen que venir con algunas de las fotografías para que las revisen y sobre todo en la sesión larga vamos a trabajar con las imágenes que el señor Siedler trae para trabajar sobre ellas y ya después, como lo habíamos dicho, primera sesión, conferencia. Segunda sesión es el training basado principalmente en las fotografías que trae él. La tercera sesión, él va a estar en Oaxaca impartiendo otro curso, entonces mientras tanto nosotros vamos a hacer un trabajo de prueba para poder aplicar los conocimientos adquiridos en el training y ahí entonces se van a generar cualquier tipo de duda o pregunta necesaria y luego ya el jueves y el viernes nuevamente hay otra sesión en donde él va a estar presente y podremos entonces resolver las dudas que tengamos al momento de querer aplicar el programa. Si alguien tiene más dudas, pues también ahorita digo más dudas acerca de la organización, ¿verdad? Bueno, pues muchísimas gracias por todo y nos vemos entonces durante esta semana.